Good morning everyone. Today we will do exercise 12.2 of chapter 12, which is based on this topic, use of exponents to express small numbers in standard form. It means how to express very small numbers in standard form. Children, in your previous class you have learned about how to express large numbers in standard form. So let us recall that if a number is 14960000000 meters, so how to express it in standard means exponential form. As you can see, leaving this first digit, we have total number of digits are 1 2 3 4 5 6 7 8 9 10 11. So it becomes the exponent. 11 becomes the exponent. 10 raised to power 11 is the power. So 10 raised to power 11 is the exponential form. Then now we have this number 1496. We'll not take these zeros, so it becomes, after 1 we have to put decimal. So after 1 we'll put decimal 1.496. These zeros will not be included in this number, so it becomes 1.496 into 10 raised to power 11 meter. This is how we can express very large numbers in standard form. Now as you can see, 0.000007 is a very small number. How to express it in standard form? So when we remove this decimal sign, you can see there are how many digits after decimal? 1 2 3 4 5 6 digits. So when we remove this decimal, it becomes 7 by 1 upon 7 by 1, 6 zeros along with 6 zeros. So it becomes 10 raised to power 6, and when we take this 10 raised to power 6 in the numerator, it becomes 10 raised to power minus 6. As I told you, to make any exponent negative, to make any exponent positive, we always reciprocate the base, right? Similarly, if we want to make any positive exponent to negative exponent, again we have to reciprocal the base. So here you can see 6 is a positive exponent, but it has to go in numerator, so it becomes a negative exponent. So it becomes, the number becomes 7 into 10 raised to power minus 6. Or simply what we can do is, if in short way you have to solve this sum, you can do is, here is the decimal. Now as you can see, 7, after 7 there is no digit, so this decimal will have to shift after 7. So between this decimal and this decimal we have 6 digits. So in very small numbers we always use negative exponent. It becomes 10 raised to power minus 6. Why minus 6? Because between this and this decimal, which we want to put, between these two decimals there are 6 digits. So 6 digits will become 10 raised to power 6, and minus sign, as this is a very small number, so they are represented by negative sign. So 10 raised to power minus 6, and this number, now will not take these zeros, only 7.0 we can take, or simply 7. So it becomes 7 into 10 raised to power minus 6 as this standard form. Now you can see the number is 0.0016, right? So one method is we can write it as 16 by, as you can see there are 4 digits, so 16 by 10,000. 10,000 means 10 raised to power 4, but it is a 2-digit number, so 1 digit we have to adjust here. 16 by 10, so we are left with 1 by 10 raised to power 3. As it has 4 zeros, 1 zero will come here below 16, and we are left with 3 zeros, that is 10 raised to power 3. So when it will go in numerator, it becomes 10 raised to power minus 3, and this number becomes 1.6. So 1.6 into 10 raised to power minus 3 is the standard form. Or what you can do is, as I told you, after zeros 1 is the digit, right? After zeros we have 1 as the digit. After this 1 we have to put decimal now. So between this decimal and this decimal we have 3 digits, so it becomes 10 raised to power 3. As I told you, this is a small number, so in small numbers we use negative exponent. So this becomes 10 raised to power minus 3, and this number becomes, leaving these zeros we are left with, now this decimal will shift here, so it becomes 1.6. So it becomes 1.6 into 10 raised to power minus 3 as the standard form of this number. Now coming to exercise 12.2, we have Express the following numbers in standard form. We have 5 parts, so let us see. So the first part is 0 point. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 zeros, then 8, 5. As you can see, this is again a very small number. So we have to put decimal here after 8. So between this decimal and this decimal, we are having 12 digits total. 11 zeros and 1 is this number 8. Total 12 digits. So into it becomes 10 raised to power 12 and minus, as this is a very small number, so it will be shown by negative exponent minus 12. And now we will not take these zeros. The number left is, now this decimal will come here, it becomes 8.5. So 8.5 into 10 raised to power minus 12 is the answer of this part. Or you can do it like this also. This is the other way out. So you can see these are total 11 zeros, 12, 13 digits. So it will be written as 85 divided by 10 raised to power 13. And it is a 2-digit number. 1 0 we will adjust in the denominator of 85, and we are left with 12 zeros, 10 raised to power 12. So it goes in numerator, it becomes 10 raised to power minus 12, and 85 by 10 becomes 8.5 into 10 raised to power minus 12 as the standard form of this part. Right, coming to second part. So as you can see, this is a very small number again. 0 point something is a small number. So to express small number in standard form, we'll just count the zeros. 3, 3, 6, 3, 9 to 11. And now this decimal sign will have to come after 9. Right? After the digit except 0, the decimal will come after that number. Now between this decimal and between this decimal, which we have to put, right, between these two decimals we have total 12 digits. 11 zeros and 1 number is this, 12 digits. So the exponential form becomes 10 raised to power minus 12. Why minus? Because this is a small number. When decimal shifts from left to right, this decimal will remove from here and it will come here. So we always use it by negative exponent. Or you can say, when we have to express very small numbers in standard form, we always use a negative exponent. So this number becomes 9. We remove these zeros. These zeros will not be considered now. So this decimal is shifted here only. So it becomes 9.42 into 10 raised to power minus 12 as the standard form. Now coming to third part, 6, 0, 2, and these are 3, 3, 6, 3, 9, 3, 12, 13 zeros. As you can see, this is a large number. We do not have this 0 point like that. This is 602 simply with 13 zeros. 11 zeros. 3, 3, 6, 3, 9, 9 and 3, 12, 13 zeros. Yes. Now what you have to do is you have to consider in very large numbers, you will consider decimal at end. Now this decimal have to shift after the first digit. Right, after 6. Decimal will come after 6 now. So between this decimal and this decimal, we have total 13 zeros, 14, 15, total 15 digits. And in very large numbers, we use positive exponents, 10 raised to power 15. And now this decimal is shifted after 6. So it becomes 6.02. We'll not consider these zeros. After 2, all the zeros will not be considered. So this number will become 6.02 into 10 raised to power 15. Why 15? Because leaving 6 we have 15 digits. So it becomes 10 raised to power 15. Always leave the first digit. Other digits will come in the power form. 10 raised to power 15. And this, in large numbers, we always consider decimal at end. And this decimal has to come after first digit. So between this digit and this digit, we have 15 digits. It becomes 10 raised to power 15, and this number becomes 6.02. Now again coming to this part, this is again a very small number. So we have 3, 3, 6 to 8 zeros, and the next number is 8. So total 9 digits are there. So it becomes 10 raised to power minus 9, and this decimal will come here now, and this number becomes 8.37. Coming to fifth part, 3186 with 7 zeros. Now again this is a large number. We'll consider decimal here. Now this decimal will have to come after first digit, that is after 3. So between this decimal and this decimal we have total 7 and 3, 10 digits. right? So it becomes 10 raised to power 10, and this number becomes 3 point, now this decimal will shift from here and it will come here, 3.186. Will not consider zeros after the last digit except 0. Like here you have taken after 2, all the zeros will not be considered. Here after 6, these zeros will not considered here because these are already included in this exponential form. So it becomes 3.186 into 10 raised to power 10 as the standard form. So this completes question number 1. Coming to question number 2, express the following numbers in usual form. Now we are given the sum in exponential form, standard form. We have to convert it into decimal form or into a small or large number. Now you can see 3.02 into 10 raised to power minus 6. As the exponent is negative here, to make it positive, we'll take it into the denominator. So when we shift this minus 6, 10 raised to power minus 6 in denominator, the exponent becomes positive. And in numerator we have 3.02. We'll remove this decimal, and after decimal we have 2 digits, so it becomes 100. So total there are 10 raised to power 6 means 1 with 6 zeros, and 7th and 8th zeros are these two. So total we have 8 zeros in the denominator. Now convert this number into this fraction into decimal number. 8 zeros, and in numerator we have 3 digits, so it means 1 2 3, and we have to put 5 more zeros in front of this 3 and then 0.0. So this decimal form becomes 0.000000302. Why these zeros have come? So as you can see, there are 8 zeros in the denominator. We need 8 digits in the numerator. So if I put zeros here after 302, so it will not, it will no more be a 302. It will not become a 302 number, right? To make it 302, we have to put zeros in front of 3 because zeros on the left side have no value. So we'll complete the 8 digits. 3 digits are already there, and we'll put 5 more zeros. So 203, 5 more zeros, then we'll put decimal, and this 0 will come. So it becomes 0. This is the usual form. Coming to second part, 4.5 into 10 raised to power 4. Now you can see this is a positive exponent, so we'll not take it in the denominator. It will remain in numerator only. So 4.5 will become 45 by 10 when we remove this decimal. 1 0 cancels with, these are 4 zeros, 1 0 cancels with this 1 0, so we are left with 45,000 as the answer. Third part is 3 into 10 raised to power minus 8. Again we have negative exponent, so we'll shift this number in the denominator to make the exponent positive. 10 raised to power 8 means 1 with 8 zeros. So again we have only one number, so it means we have to put 7 zeros in front of 3 to make it a decimal number. So it becomes 0.7 zeros, then 3. Total 8 digits because 8 zeros were there. So this is the usual form. Coming to fourth part, 1.0001 into 10 raised to power 9. When we remove, as you can see, this is a positive exponent, so we'll not shift this number into denominator. It will remain here. We'll remove this decimal sign, so we'll get, after decimal we have 4 digits, so it becomes 10,000, and we have 9 zeros here. 4 zeros cancels with 4 zeros, we are left with 5 zeros. So 10001 into this 1 lakh becomes 10001 with 5 zeros is the answer. Now coming to fifth part, 5.8 into 10 raised to power 12. Again it is a positive exponent, so we only change this 5.8 into 58 by 10, removing the decimal. 0 cancels with 1 0, so we are left with 11 zeros. So 58 multiply with this number gives 58, 58 with 11 zeros. So this is the usual form of this number. Coming to sixth part, 3.61492 into 10 raised to power 6. Again a positive exponent number is there, so it will remain here. We'll remove this decimal and 1 with 5 zeros come. These 5 zeros cancels with 5 zeros. We are left with 1 zero only because there were 6 zeros in the numerator. So answer is 3614920 as the answer of this part. This is the usual form. So this completes question number 2. Coming to question number 3. Express the number appearing in the following statements in standard form. Now these are statements given to you. It's very simple. You just have to write the standard form of each each statement. So first part is 1 micron is equal to 1 upon 1 with 6 zeros meter. Now the standard form is, as you can see, 1 upon 1 with 6 zeros. So can I write it 10 raised to power 6? And to make and to and then this 10 raised to power 6 has to be kept in numerator. So to take this 10 raised to power 6 in numerator, we have to make this exponent negative. So it becomes 1 into 10 raised to power minus 6 meter in the, this is the standard form of this statement. Coming to second part, charge of an electron is 0. These are 3, 3, 6, 3, 9, 3, 12, 15, 18 zeros with 1, 6 coulomb. So its standard form is, again, this is a very small number. So decimal will shift from here to after 1. So we have total 18 zeros plus 1 this digit, 19 digits between these two decimals. So it becomes 10 raised to power minus 19. Why minus 19? Because this is a small number and small numbers are always represented by negative exponents. 10 raised to power minus 19 and this becomes 1.6. So the standard form is 1.6 into 10 raised to power minus 19 coulomb. Then size of bacteria is 0.605 meter. So you can see this decimal will come after 5. So between this decimal and this decimal we have 7 digits. So it becomes 10 raised to power minus 7 meter. And 5, after 5 there is no digit, so it will come only 5. So standard form, or you can write 5.0. 5.0 or 5 is one as the same thing. So 5 into 10 raised to power minus 7 meter is the standard form. Now coming to the fourth part, size of a plant cell is 0.40, then 1275 meter. So you can see after this decimal is to be shifted after 1. So between this decimal and this decimal we have 5 digits. So it becomes 10 raised to power minus 5 meters. And this number becomes 1. Now this decimal will come here. So it becomes 1.275 into 10 raised to power minus 5 meter as the standard form of this part. So this last part is thickness of thick paper is 0.07 mm. So you can see after this decimal has to shift after 7. So between this decimal and this decimal we'll get 2 digits only. So it becomes 10 raised to power minus 2 mm and the number left is 7 only. So it becomes 7 into 10 raised to power minus 2 mm. You can write as 7.0 also. So 7 into 10 raised to power minus 2 mm is the standard form of this part. So this completes question 3. Coming to question 4. In a stack there are 5 books, each of thickness 20 mm and 5 paper sheets, each of thickness 0.016 mm. So what is the total thickness of stack? Stack is a bundle of books or bundle of sheets. So as you can see, the thickness of one book is given 20 mm and there are 5 books. So what is the thickness of 5 books? 20 into 5, 100 mm. Thickness of one paper sheet is 20 mm. Thickness of one paper sheet is 0.016 mm. And we have to find thickness of 5 paper sheets. So 0.016 into 5 gives 0.080 mm. And we have to find the total thickness of stack. Right, total thickness means thickness of 5 books and 5 paper sheets. Their sum gives the total thickness of stack. So 100 plus 0.080 makes it 100.080 mm. Now again we have to convert it into standard form. Now you can see this is 100.080, right? So whenever we have decimal in between, it will always come in the front side, right? So it becomes 1.0008. This 0 will not be considered in 2. Now between this decimal and this decimal we have 2 digits. So it becomes 10 raised to power minus 2. So this is the standard form of this number, 1.0008 into 10 raised to power 2 plus 2. Whenever decimal will shift in the front, we'll express it with positive exponent. So 1.0008 into 10 raised to power 2 mm is the total thickness of this stack. So I hope these questions are clear to all of you. This completes your exercise 12.2. Thank you so much.